Hello students! Welcome to Math&Magic. For today's video, I will discuss combined variation. By definition, a variation is referred as combined variation if one quantity varies directly or jointly as the other quantities and inversely as other quantities. In short, independent variables are being multiplied and divided for this type of variation. Its form varies depending on what are given in a problem. The simplest can be written as y equals kx over z, and read as y varies directly as x and inversely as z, where y is the dependent variable, k is the constant of variation, and x and z are independent variables. Here, the constant of variation is given by k equals yz over x. This is done using algebraic manipulation. Again, this formula is true only for this variation statement. Formula of constant in combined variation may vary for other examples. Now, to better understand this variation, here is our first example. If A varies jointly as B and C and inversely as the square of D, A is 15 when B is 5, C is 4, and D is 2. What is A when B is 6, C is 5, and D is 3? Take note that the solution for combined variation is somewhat similar to a joint variation. Here we will solve for the constant of variation, formulate the variation equation, and from this, we are going to solve for the missing quantity. In this case, that is the dependent variable A. For this, we will have A equals KBC over D squared. Solving for K, we will multiply A and D squared. Now the product will be divided by the product of B and C. Substituting the values, K is 15 times 2 squared over 5 times 4. 2 squared is 4 times 15, the product is 60. For the denominator, 5 times 4 is equal to 20. Dividing 60 by 20, the quotient is 3. Next, we will substitute K in the equation earlier. Hence, the variation equation is A equals 3bc over d squared. Lastly, solving for A, equation will be 3 times 6 times 5 over 3 squared. In the numerator, the product of 3, 6, and 5 is 90. While in the denominator, the square of 3 is 9. Dividing 90 by 9, the quotient is positive 10. Hence, the value of the dependent variable is 10. For our second example, the current denoted by variable I varies directly as the electromotive force variable E and inversely as the resistance variable R. If a current of 30 amperes flows through a system with 16 ohms resistance and electromotive force of 120 volts, find the current that a 200 volt electromotive force will send through the same system. For the solution, we will form first the equation. It is stated that the current I is directly proportional to E and inversely as resistance R. Equation will be I equals KE over R. Solving for the constant variable K, it will be K equals IR over E. Substituting the given in the second statement, equation will be K equals 30 times 16 over 120. 30 times 16 is equal to 480. 480 divided by 120, the quotient is positive 4. Thus, the constant of variation is positive 4. Now, solving for the current I, when electromagnetic force E is 120 and with the resistance of 16 ohms, here R is still equal to 16 ohms since according to the problem, it will be sent through the same system. Performing the operations, 4 times 200 is 800. Simplifying 800 over 16, the current I is 50. Hence, the current for this problem is 50 amperes. Now to summarize, there are 4 types of variation. First is the direct variation. Here, as the independent variable increases, the dependent variable also increases. Second, inverse variation. Here, when the independent variable increases, the dependent variable decreases. For joint variation, as the independent variables increases, dependent variable also increases at different magnitude. And lastly, for mixed or combined variation, here independent variables appear as direct or joint and inverse. Also, dependent variable may increase or decrease depending on the independent variables in the numerator and denominator. Now here are some practical applications of combined variation. Thank you for watching. God bless.